In this video, we are going to see the load test on single phase induction motor. So the aim of this experiment is to conduct load test on single phase induction motor to find the efficiency and also to draw the performance characteristic curves. So the apparatus required for this experiment were first thing is your ammeter in the range of 0 to 10 amps, and next is voltmeter in the range of 0 to 300 volt, and next is wattmeter in the range of 300 volt 10 amps, and it is UPF meter, which means it is unity power factor meter. And next thing it is single phase auto transformer. Its range is 0 to 270 volt. And next we are in need of a tachometer, so and some connecting wires. So these are all the apparatus required for conducting this load test on a single phase induction motor. So before starting the experiment, what are all the precautions that needs to be done before starting? So first thing is the motor should be started without any load. So usually we'll do the same thing. So if you are performing the load test previously, we have to ensure initially no load is being applied to the circuit. So next thing is the supply should not be switched off before the motor is unloaded. So motor unload பண்ணாம, which means without load condition க்கு கொண்டு வராம we should not turn off. Next is while running on load, brake drum is cooled by pouring cold water. Yes, this also we knew it. ஸோ பிரேக் ட்ரம்மில் நம்ம மெஷின் லோட் அப்ளை பண்ண என்ன ஆகும், லோட் அப்ளை பண்ண என்ன பண்ணும் அப்படின்னா we have to cool the brake drum by means of using water. These are all the precautions that needs to be done before starting the experiment. Now I'll show you the circuit diagram for conducting this experiment, and this is what the circuit diagram for load test on single phase induction motor, and this is the representation of a single phase induction motor. So here we are having main winding, also you are having auxiliary winding. So first, this is what the input supply, it is going to be 230 volt 50 Hz supply. As we know, it is the single phase AC supply. So fuse rating usually will be selecting or will be using the fuse by means of using a formula that is 125% of the rated current. So the rated current, rated power, and its voltage and all those things, everything is being given in the nameplate details. And this is what the auto transformer. So after that, from the auto transformer, it is being connected to a ammeter which is in series with the input, and again a voltmeter is connected across the input supply. And next you are having a wattmeter. In wattmeter you are having four terminals, four connecting points. Those were M, L, C and V. So always remember this MC should be in short condition. So this MC should be shorter. So next we are having the main winding. So the line terminal is being connected to the one end of the main winding, and again you are having a capacitor, that is C1 C2 point. So that is being connected with this M1. Again C2 is being connected to this one end of this auxiliary winding. So the other end of the main winding, also this auxiliary winding is connected to the negative end of the supply. So next, this is what the load which is being connected to the motor. So before starting the experiment, you have to ensure this load, that is here will be, this is the spring balance, here you will have a reading. So that needle should point 0 before starting the experiment. So this is what you have to done before starting the experiment. So this is what the laboratory setup for conducting the load test on single phase induction motor. So these were the ammeter and voltmeter and wattmeters. that is being connected, and this is what the auto transformer. So this is what the laboratory setup, and here you are having main winding, auxiliary winding, and C1 and C2, all those things which is being connected in the panel. And this is what the input supply, that is phase and neutral, this was there, everything is connected in the panel. So at the right side you'll be having the motor. So this is being which means the connections were given to the board actually, and the motor is placed at the nearer side. So now let's see how we have to conduct this experiment. So for this, the connections as I have shown you in the laboratory setup, you have to connect as per the circuit diagram. So ensure this motor is in is not in loaded condition, which means it is unloaded. So ensure that it is not in loaded condition, and also the auto transformer is at its minimum position. So after ensuring this, the DPST switch is closed. Now the motor is brought to its rated speed by adjusting the auto transformer. So you have to adjust the auto transformer, and you have to set the motor to its rated speed. So initially the spring balance will show a 0. So now you have to note down the ammeter, voltmeter, and wattmeter readings, which is tabulated. So and speed also, the spring balance reading in the tabular column for different values of the spring balance, that is for different values of different load which is being applied, you have to take different readings. So that is the load is added to the motor gradually, you have to increase the load. So for each load you have to measure this voltmeter, ammeter, wattmeter, and spring balance readings, also the speed of the motor. So you can conduct this experiment until the rated current is reached. So after that you can stop the experiment. So before turning off the machine, you have to ensure whether the no load is, whether the motor is unloaded and the auto transformer is in its minimum position. Also by making all these in proper setup, you can turn off the supply. So now let me show you the tabular column for this experiment. So this is what the tabular column. So the same thing, you have to note down the line voltage, load current. Next is your spring balance readings, that is S1 and S2. So this is S1 difference S2, that is you have to take the difference between these two load applied, and this is what is speed. The speed you'll obtain it from the tachometer. And next this wattmeter, we are having the wattmeter, right? So you have to calculate the wattmeter, you have to take the readings from the wattmeter. And this MF, it is the multiplication factor. So this value will be at the back of the meter which you are using. So from that you have to check what is the multiplication factor, we have to use it, and you have to multiply this wattmeter reading with that multiplication factor, and you have to write here. And this is what the input power. And next you have to calculate the torque, output power, power factor, slip, and efficiency. For the all these parameters you are having the formula, so that I'll show you. So this is what the formula for calculating torque, output power, and the efficiency. So for calculating the efficiency, you're having the formula as P naught divided by P into 100. Similarly for power factor, slip, and this is what N is the synchronous speed. By means of using this synchronous speed, you can calculate the slip of the machine. So next you have to plot the graph. So the graph is being plotted against output power and speed, power factor, load current, and efficiency. So next again a graph is being plotted against slip and torque. So this was the graph that you have to draw by means of using the readings you have obtained. So this is what the load test on single phase induction motor. So in this way you have to conduct the load test on single phase induction motor, and you have to draw the performance characteristics. Also you have to find out the efficiency of the machine. Thank you.